The next rule gets its own video. It doesn't have to share because the product and the quotient rule are kind of the same rule. They're very, very close to each other. Power rule, though, that's what we're going to talk about next. So we're going to start with example 6.5 that wants us to expand 2 cubed squared. Now remember what it means for something to be squared. That means multiplied by itself. So this really becomes 2 cubed times 2 cubed. Oh, so as soon as we write the power, expand the power, now this is just the product rule, just like we did before. 3 plus 3 is 6. So this just becomes 2 to the 6th. And that's, it didn't ask us to do more, but we could extend this, right? 2 cubed to the 4th. That'd be 4 of them. 2 cubed times 2 cubed times 2 cubed times 2 cubed. Now there are 4 3s that we're adding up together, and we'd get 2 to the 12th. So notice what's happening with these exponents. 3 and a 2 becomes 6. 3 and a 4 becomes 12. That's it. If you said it out loud, you probably said that we're multiplying them. You probably yell out loud while you're watching your math videos. I hope you do. If you're not yelling out loud while you're watching math videos, what are you? I think you're doing it wrong. So let's talk about the power rule. So as long as everything is well behaving, if we have an exponential function and an exponent on the outside of parentheses, then we multiply those exponents together. Okay? And this works when there's multiple stuff on the inside as well. Just kind of do it for each one. So let's do example 6.6 together. That wants us to expand first and then use this next power rule that we haven't technically introduced yet. So a cubed times b squared squared. Eventually I'll say we can just square both of these. But let's show why it works first. So this is a cubed b squared. And this thing is getting squared, which means it's multiplied by itself. That's what squaring something means, multiplying it by itself. Well, now it's just like before. Multiplication can be done in any order, right? We don't have to worry about order of operations for these 4 things because it's all multiplying. It's all the same operation. Do it any order. A cubed times a cubed is a to the 6th. B squared times b squared, add those exponents up, b to the 4th. So this thing that we talked about in the first one also happens in the second one. We can just multiply as long as the insides have no addition. Addition's a squirmy little thing in math. But as long as everything's just multiplied, we can just multiply those exponents. Okay? So we got the old pop coming up next. Not your father, but the power of a product rule. So as long as everything's behaving nicely, now if I have 2 things raised to an exponent that are being multiplied by each other, then each one can get that exponent. So we got a really spooky skull and crossbones. Look, they really did a good job with this one. Let's zoom in. Warning, you don't want to end up like this person. It's important to be careful to only use this rule when things are multiplied. If there's addition on the inside, addition is bad. This doesn't work. And the reason why that doesn't work is because of foiling, right? If you have something like this, this is not equal to a squared plus b squared because, right, if something is squared, that means it's being multiplied by itself. So a plus b times a plus b, and to multiply 2 binomials is the word. First, outer, inner, last, you got to multiply this all out. You got to FOIL. A lot of people don't like foiling, so I'll have a little sad face. Kind of looks like Homestar Runner to me. Probably none of you even know who that is, but you can Google it if you want a little internet history lesson. Let's do another example. Let's utilize these rules that we've talked about. Example 6.7. That 7 looks a little sad. All right, evaluate by expanding first. We're going to introduce a new kind of power rule. There's all sorts of power rules. I said the power rule gets its own video, but really it's because there's a bunch of power rules all kind of in one. So if I have a over b cubed, hopefully at this point you have a suspicion of what's going to happen. Hopefully your spidey senses are tingling. But right, this is a over b. We don't need parentheses here. Times a over b times a over b. Well, we're multiplying fractions. We can just multiply the numerators, a times a times a, and multiply the denominators, b times b times b. And there we go. That's going to be our next property. That, yep, as long as things are being divided, it's just like division's just like multiplication. Division is almost exactly the same thing as multiplication. So the rules for division are often very similar to the rules for multiplication. And that brings us to our next one. If the last one was pop, this one is POC. They don't even give the abbreviation because they say nobody wants to say POC. All right, so as if we're exponentiating a fraction, we can just exponentiate the numerator and the denominator. All right, so now let's put all these rules to the test and get exampling. It's a real word, exampling. 6.8, last example of the video. We got 5a to the 4th b cubed. Things are getting multiplied, no additions happening. That's good. So we can just give each one of these things multiplied that exponent. So this is going to be 5 cubed. This is going to be a to the 4th cubed. And this is going to be b cubed. And we can evaluate each one of these and smush them all together. So 5 cubed, you can use a calculator, it should be 125. We have an exponential function raised to another exponent. We multiply those exponents together, get a to the 12th. And b cubed is just kind of sitting there. We don't have to actually write these multiplication signs. We can just put them next to each other. Voila, we have our answer. Now b is going to be pretty similar, but a little bit messier. We got 5m cubed divided by 9n to the 4th, and that's all getting squared. Now there's a couple of orders on which you can kind of approach problems that look like this. You can either start by simplifying the inside or start by simplifying the outside. But if you look at just the inside, there's 5 divided by 9 can't be reduced. We have m's and n's, those can't be combined. So here we got to deal with this squared. We just had the property that said if we have a fraction, we square the top, square the bottom. So this will be 5m cubed squared and 9n to the 4th squared. And we will just continue using properties. We're squaring a product. That means we square each one. So that's 5 squared times m cubed squared. This is 9 squared times n to the 4th squared. And I go through these pretty quickly. Feel free to pause or slow down the video as you need. 5 squared is 25. Just like before, we're going to multiply these exponents. M to the 6th. 9 squared is 81. Multiply the exponents. N to the 8th. Nothing reduces or cancels. That's our final answer. And we're very happy about this one. Give yourself some happy faces on the, oh, I gave the happy face eyebrows and now it looks very skeptical. That's your answer? That's why I stopped giving video on my audio feedbacks. No, that's also a lie. Imagine just watching me grade your assignment and I look at your problem and I go, that wouldn't be good. I don't think I make that face when I grade, but you never know. Sometimes we don't know what our faces look like until we watch a video of ourselves. Same with our voice. From teaching, I get to do both all the time, and I've realized that my face and my voice are both very interesting. Last one in this video. You survived, or hopefully. Got a lot of things going on here. Let's simplify things one at a time. Let's deal with this. Exponential with another exponent, multiply those exponents. We get x to the 6th. Y to the 4th, let's just let y to the 4th sit tight for a little bit. Bottom, two things multiplied by each other getting exponentiated. We'll do each one, x cubed, y cubed. And now we get to use the quotient rule from before, right? X to the 6th, x cubed, they're being divided. Same base, we subtract those exponents. 6 minus 3 is 3. Same thing with the y's. 4 minus 3 is 1. We usually don't write the 1. Y is the same thing as y to the 1st power. And what happened to our denominator? We technically have a denominator. Our denominator is 1. Because everything else went away, there's only a 1 left over. Anything divided by 1 is just that thing. Okay, so these are the same thing, but we usually don't write this step. And this is the video on the power rule. There are multiple of them. All right, good luck.